So question 1 is just a simple inductor with an AC supply, and we're asked to find the inductive reactance XL and the series current. So XL is equal to 2 pi times the frequency F times the inductor value L. So if we're told that the frequency is 50 Hertz, I'm going to make the inductor value 0.3 Henry. So XL is 2 pi times 50 Hertz times 0.3 Henry. So on the calculator we do 2 shift to get pi times 50 times 0.3, 94.248. I wouldn't round too much at the start. I would use 5 decimal places, I would say, or just keep the answer in your calculator. I'm going to store XL in a memory location. So this is XL, and I'm going to click store, and then I'm going to choose, you've got A, B, C, D, E and F. I'm going to choose memory location A. So now when I press alpha and A, it's got my number stored. But if you don't want to store it in your calculator, I would use probably, say, 5 decimal places approximately, so that any answer that comes after that isn't affected by your rounding. To be fair, it doesn't hurt to put the full answer in anyway. So that's XL. That's part A. And then part B relies on part A. That's why it's good not to round it to start with. So the series current from Ohm's law, I is usually V over R. But we don't have a resistor here, we have a reactance. So the current is the supply voltage divided by the amount of ohms, or the reactance, which is XL. So the current is, you can see, 100 volts divided by this answer, 94.24, etc. Now if I've stored, or I've kept the, if I haven't turned my calculator off, this answer for XL is already also stored in the answer section, because it was the last thing I calculated. So if I want to do 100 divided by that, do 100 divided by my last answer, which was 94.24 and so on. 1.061 is the current. And that is in amps. So that's how you do the first question. If I wanted to use the memory location that I'd stored XL in earlier to find current, I would do 100 divided by the number that I stored in A. Gives me the same answer. So question 2 is very similar. We have just a capacitor and an AC supply. The capacitor has a value of 1 microfarad, or 1 millionth of a farad, which is 1 times 10 to the minus 6 farads, and we're asked to find XC, the capacitive reactance, and the series current. So we'll start with XC. That's the reactance of this capacitor in ohms, and it's 1 over 2 pi times the frequency times the capacitance. So XC is equal to 1 divided by 2 pi times 50 Hertz again, that's F, times 1 times 10 to the minus 6 farads. So on the calculator you can use the fraction button if you like. 1 divided by 2 pi. It's also divided by 50 Hertz. And this is important. 1 microfarad is 1 then you press times 10 to the x, which gives you the power of 10. 1 times 10 to the power of minus 6, and that gives us a value of 3,183 ohms. That's the capacitive reactance. So XC is equal to 3,183 and the rest 0.098862 ohms. So that's how many ohms are opposing the current flow. I would keep it like this for now unless you're told to round to a certain amount of decimal places. Straight away, so that's part A. Straight away we can do part B, the series current. Normally current is voltage divided by resistance, but we don't have a resistance, we have a reactance. So I is equal to the supply voltage divided by the amount of ohms, or XC. So that is 100 volts divided by our last answer for XC, 3183 and the rest. So I do 100 divided by my last answer, which is 0.031 amps, and I've written that to 3 decimal places. The next question is a 5-mark question. It is a resistor inductor or RL circuit, a series RL circuit. Voltage supply is 400 volts and the frequency is 50 Hertz. We've got a 100 ohm resistor and a 15 millihenry or 15 times 10 to the minus 3 Henry inductor. We're asked to find XL, the impedance, the series current and the power factor. So as before, XL is 2 pi times the frequency times the inductance, which is 2 pi times 50 Hertz times the inductor value, and this is important, it's 15 milli, so it's 15 times 10 to the minus 3 Henry. So on our calculator, let's work that out. 2 pi times 50 times 15 milli, 15 times 10 to the minus 3 Henry. And don't confuse milli and micro. So milli is 10 to the minus 3, micro is 10 to the minus 6. So the amount of ohms of reactance that this inductor has is 4.71238898 ohms, and you will be asked to round to a certain number of decimal places, but because we're going to use this value next, I'm not going to round it for now. That's part A. Part B is the impedance. So we have resistance on the x-axis, inductive reactance on the y-axis, and the impedance Z is the hypotenuse. So we use Pythagoras for this. So Z, the hypotenuse, is the square root of the other two sides squared and added. So it's the square root of R squared plus XL squared. So that's the square root of R is 100 ohms, which we're given in the question, and XL we've just worked out, 4.7123, etc. So on my calculator for Z, all I need to do, because we already have XL as the last answer, I can do the square root of 100 ohms squared added to my last answer squared. And the 4 ohms won't make much difference to the impedance because it's a lot smaller than 100, so it'll be around 100 anyway, I would have thought. There we go, so the impedance is 100.111 to 3 decimal places ohms. Now we can do part C. The current is equal to the voltage, and instead of resistance for Ohm's law, we have to use the overall amount of ohms, because resistance is ohms, reactance is ohms, but we have to use the total amount of ohms, which is the impedance. So current is voltage divided by the overall amount of ohms, impedance. So that is, the voltage here is 400 volts. 400 volts divided by Z, 100.111. So I can just on my calculator type 400 divided by the last answer, and that is 3.9955 or 3.996 amps to 2 decimal places. If we were asked to round this, sorry, to 3 decimal places, that was. If we were asked to round this to 2 decimal places, because the 5 is 5 or more, that would make this round up and it would actually become to 2 decimal places. This would be 4.00 amps. But in the exam, you won't have to worry, your answers will be a little bit nicer to round. Finally, the power factor is the adjacent, the real amount, which is resistance, compared to the apparent amount, which is the hypotenuse. So it's really easy to do. It's resistance divided by impedance, which is 100 divided by 100.111. So this is going to be a power factor that is very good, close to 100%. So do 100 divided by 100.111, 0.999. So that is basically very close to 100%. It's 99.9% power factor. This is another 5-mark question, but it is an RC, or resistor capacitor circuit. We're finding the capacitive reactance, XC, then the overall amount of ohms, the impedance, then the current and power factor. XC is 1 over 2 pi FC, and that is equal to 1 over 2 pi times the frequency, and we're given the frequency, it's always in hertz, 50 hertz, and the capacitor value is 2.2 microfarads. So that is 2.2 times 10 to the minus 6 farads. So on our calculator, 1 divided by 2 pi times 50 hertz times 2.2 micro, or 10 to the minus 6. So our capacitive reactance is 1446.863119 ohms. So that's part A. Part B, we find the impedance. So here we have the resistance R, and down here is the capacitive reactance that we just worked out, and then the impedance is the sort of the sum of the two, but you can't just add one to the other, we have to use Pythagoras. So said the hypotenuse is the square root of the adjacent side squared plus the opposite side squared. That's equal to the square root of our resistor is 130 ohms. And then XC and XC we just worked out. Don't forget to square it because it's Pythagoras. So Z is going to be the square root of the resistance 130, then you press the X squared button, added to our last answer squared. So Z is 1452.692 if we're doing it to 3 decimal places, say. So we've done XC, we've done Z. Now we can do the current. I is V over Z, which is 100 volts supply voltage there. I've just drawn a terrible arrow to show you where it is. 100 volts divided by 1452.692 ohms. So on my calculator I do 100 divided by that last answer because I've just worked out Z, and it is 0.0688, etc. So if we were going to do this to 3 decimal places, this last 8, the third decimal place would round up because of this last number. So the current is 0.069 amps. So that's that done. Now the power factor is always going to be, whether it's a RC, RL or RLC circuit, it's going to be the adjacent divided by the hypotenuse, or the resistance divided by the impedance. It's going to be 130 ohms divided by Z, 1452.692. So I'll do 130 divided by 1452.692. So the power factor is 0.089. And if you want that as a percentage, we can multiply that by 100. So the power factor is 8.95, which is a terrible power factor because we're only getting roughly 9% of our power going through the load or the resistor. But that's what it happens to be. So this is the hardest type of question that you will encounter, but it's still not too bad. We have a resistor, an inductor and a capacitor, so it's known as an RLC circuit. So we're asked to find the inductive reactance, capacitive reactance, the overall impedance in ohms, and then the current and power factor. So we know that XL is equal to 2 pi times the frequency times the inductor value. So that's 2 pi times the frequency, which is 1 times 10 to the positive 3, or 1 kilohertz or 1000 hertz, times the inductor value of 90 millihenries, which is 90 times 10 to the minus 3 Henry. So we do 2 times pi times the frequency, which is 1 kilohertz, times 90 millihenry, or 90 times 10 to the minus 3. So the amount of ohms that the inductor has, the inductive reactance, is 565.4866776 ohms. And then XC is 1 over 2 pi FC, which is equal to 1 divided by 2 pi times the same frequency, 1000 Hertz, times the capacitor value, which is 1 micro, or 1 times 10 to the minus 6 farads. So XC is 1 over 2 pi times the frequency of 1 kilohertz, or 1000 Hertz, times the amount of farads we have for the capacitor, which is 1 times 10 to the minus 6. So XC is 159.1549431. I always write the full amount down in case I need to use it later on. And because that is a reactance, it's in ohms. So what we have is the resistance, the inductive reactance at 90 degrees, then the capacitive reactance at minus 90 degrees, and if XL is bigger than XC in length, then XL take away XC is going to mean that the impedance Z is up there. If XC was bigger than XL, then the impedance would be down there, but it doesn't make any difference to the actual amount of impedance. So Z is the hypotenuse, which is the square root of the adjacent squared plus the opposite side squared, and the opposite side over here is XL take away XC. XL take away XC, and that has to be squared because it's Pythagoras. So that Z is equal to the square root of our resistance, which is 1000 squared, plus XL take away XC all squared. But I'm going to use about 3 decimal places. So for XL, 565.487 take away XC, which is 159.155 all squared, and that will give us our impedance. So do the square root of R squared, or 1000 squared, plus then we need a bracket to do a subtraction. XL is 565.487 take away XC, which is 159.155. Close that bracket and then square it to get this squared here, and that'll tell us the overall amount of ohms. The impedance is 1079.4 ohms. That's the length of the hypotenuse. Now D is easy. I is V over Z, which is the supply voltage divided by Z. The supply voltage is 100 volts in the question. So current is 100 volts divided by the impedance, which is 1079.4 ohms. So I just type in the calculator 100 divided by that last answer of 1079.4. That gives us a current, actually comes out as 0.0926, or to 3 decimal places 0.093 amps. And then all we need to do for the power factor is the adjacent divided by the hypotenuse, which is resistance, which is 1000 ohms, divided by the impedance, which is 1079.4.